Whoa, great. Hear a little clap there. So hi everyone. My name is Alexandre Bourget. It's a fair assumption there. I will do the demo in the Emacs, and that's not true. So I'm Alexandre Bourget, CTO at StreamingFast, one of the core devs of the graph. I'm really stoked to be with you guys today. I'm in that shitty place here, but I'm super happy I can bring that Firehose thing to you guys. I think it'll be great. So first of all, I want to say that people in this room, our team is there. So if you have any questions after the conference, please go to them. They know the whole thing, and it'll be awesome. Okay, let's start here. The Firehose is what? Okay, this is our team. Thank you. The Firehose is a means of data extraction and replication. And let me give you a little context here. We're attacking the problem of blockchain data and indexing. The goal of the graph is to index the data so that you can have queries and do things with the data that lives on the blockchain that transits through the blockchain. And so Firehose is a radical approach to tackling that issue that works across blockchain, has been proven to work on many other protocols. This thing runs on 20 other blockchains here, different implementation, different languages. And there's a few principles I want to announce to tell you here so that you feel it with me. And maybe I can announce here that the Firehose, therefore the graph, because this is technology that's going to underpin the graph's indexing tech, is coming to Solana. So all these Solana folks, all of you guys will be able to index a lot of things because there's a lot of data there on Solana with the graph protocol. Okay, so to give you a little bit idea, I've got technical folks here in the room. Right? This is a dev segment. So our goal is to take blockchain nodes and extract the data out of it in the most efficient way to store it in a way that is easily retrieved and easily parallelized. And to the tech folks, I'd like to see the room. That'd be awesome. I see myself here. So the data to be easily parallelized and so that it can be consumed at high speeds. It is a files-based and streaming-first approach. What does that mean? So we take the nodes, we extract the data, put them in files so that it can be consumed from files. Files are the delight of data scientists, the delight of anyone working with data, because of the things that scale the most easily. There's no CPU machine overhead and SSDs. These things have been optimized like crazy. So we took that approach to have files on disk, but at the same time to have the fastest streaming system. And so you have a node, and imagine it's outputting the data of each and every transaction execution. And the goal is to log an output. Imagine printing to standard output, okay? Have a node, Solana validator. It's outputting everything to the standard output, any transaction being executed, any instruction being executed, and extracting thereby any state changes, but all in context of a block, of a transaction, of instruction, and of its tree, and then outpouring that, and then providing a nice and clean interface to the next consumer. Like this allows for subsystem like massively parallelized operations. And so I'll give you a few technical details there. The whole shebang has been coded using gRPC and Protobuf. So we have the deepest representation, that's about richest data around here, the deepest data representation of the different chains, and the richest, so you have all, for each protocol, even more so than the protocols do themselves in their own node, because we don't compromise on, for example, block rounding. Like we hate block rounding because when you have a block and there's few things that are happening in mid-block, like you would as well be interested in what's happening here, not necessarily like 75 transactions tweaking the same balance. If you're analyzing what happened here, you want to know the truth at that time. So we'll provide all the rich data so that your stream can be absolutely, congruous and not round things. If you're getting the state at the end, you're getting the summation of all the operations in between. Okay, so that's about the richest data. Now, the Firehose is also the only thing on Earth that I've observed, that I've seen, that handles forks gracefully and in a guaranteed way. It has guaranteed linearity. That means that, let me share my screen, something very ugly that I just whipped off this morning. it's, okay, this thing, right? You have a fork, like you have a block here, another block, and then we have some forked blocks. They get eventually forked, and this is the canonical chain here, okay? So what happens is that the stream will send you this block and this block and this block, but then it knows, it learns through the protocol that it needs to be forked out, and it'll send you a cursor. For each message, it comes with a cursor. And that cursor, if you bring it back to the connection, it's a gRPC stream, so you get disconnected, bring back the cursor, and it will continue exactly where it left off. So if it was undoing this for you, and it disconnected right in the middle here of those two blocks, it will continue doing the undo exactly where it left off, giving you sort of a guaranteed linearity of the stream. Nothing does that like that. You know, WebSocket protocol, you connect, sometimes you disconnect while it's reorganizing or whatever, and you'll miss some information. There's just no way the node will tell you that, because there's no distinction between the node and what's happening on the network. Here, the Firehose will cobble from different, for example, Solana validator nodes and merge all the fork information into, what we call 100 blocks files. We'll merge them and we'll have all the views of the perceived, forks, so you can always continue from where you left off. And also it allows the systems to be detached from the Solana validator node. Think of the whole thing as a master-slave replication protocol, right? You have MySQL, it's writing operations, but then there's that bin log replication protocol that sends it to a slave for having like increased read queries. And that's similar here. The Firehose is sort of a thing to extract and have the least burden on the node, right? The least burden on the performance. So you're not hitting that node with crazy RPC calls. No, first you output the data and you can feed just the right data to perhaps another subsystem, like a graph indexer that's putting the data in a right spot, or another system that would think about like a very lightweight system that only tracks the state for one contract, keeps it in memory, like super high speed, and then you can scale that because the Firehose replicates. You're scaling the read thing here. You're not putting more burden on the load on the Solana validator that's doing right? So think of it as replication protocol. I think it's a fair thing to say. Okay, so we have crazy perfs, file-based streaming. What else is there to say? I want to say that we've introduced the Firehose in the Graph ecosystem. So we were joined to the Graph ecosystem. And in here, if you search that, introducing the Firehose, you'll have a lot of depth. There's a document that is linked in here. It has all the spec, right? All the principles on which we base ourselves for designing this thing. So I encourage you to just search that, introducing the Firehose. You'll file it right away. And this doc is what we are bringing to Solana. Oh, you weren't seeing that, right? That's crazy. I was showing you this here, the Firehose doc, introducing the Firehose. Like search that, it has all these details and the links so that you can find the principles and all that. This is the thing we're bringing to Solana. So right now, there is a PR open in Solana land, and our goal is to have that merged so that this principle can arrive and we have it working. The thing can be piped to a graph node like in a week, let's say. And I think that's going to change really the face of what we can do on Solana. So I'll give you now a few details, what are specifics to Solana. Unless obviously there are questions in the audience. I love if someone would stand up and then would just scream out some, but someone will need to get that audio back to me. Otherwise we'll have questions from the folks on stage there. So, okay, what's specific to Solana, right? Here we have, first of all, full history. Now, do you know what that means? You know how crazy that is? Here we're talking about full history with the richness of the data that includes transaction and structured call tree and state change. I'm going to show you the Protobuf model because you all are geeks. I'm going to show you the depth of the data here, okay? So this is the Protobuf model. It's in this repository, Proto Solana, okay, tick, tick, tick. And you have that block. Each sort of thing that streams in our system is a block, and it contains all the things you would expect from a block, right? And also the transactions. Here, they're a little bit more enriched, right? Let's say a transaction will include, again, a few of the fields you're familiar with, the ID, the first signature, additional signatures, the header, whatever. But log message and instruction, this is where it changes a little bit. And each instruction, whoops, Whoa. It's crazy here. I'm new to Mac, man. So instruction. Wow. Always. What is that? I'm in edit mode. Okay, forgive that. That's crazy. Message instruction. So we have here like all the data that is needed to recreate the call tree. And when you get that information, you get it in context. You get the block, the transaction it's in, the instructions. So you can, go from the instruction to the transaction and see what was, I don't know, the first signature there, and then the instruction, and the instructions related to one another. So you can actually model a bunch of instructions as something happening, like a serum dex operations happening. You have all that information to create the tree and these little sweet things, the balance change and the account change. And you can see here, you'll see the effect of an instruction before and after you'll get the previous amount of LAMP ports and the next amount of LAMP ports for a given key. And this too, here you'll get the previous data and the full account data of what's after. And remind you get that at the instruction level, and you could squash that in a transaction level, but most systems right now just rely that as being cobbled up to the block level. So actually, this is the only way using the serum dex, we're able to extract all of the orders and fills. It's only by getting, the order book, the previous one, extracting, because we have domain knowledge of, how the thing is laid out in the account, found it from the list here, because it's sort of a queue, extract, what was there, and then the other one, the new one, and do a diff and say, oh, this instruction added that specific fill. So it's the only way. It's the only way to get something reliable. And once we have, you guys, you'll say, yeah, this is a lot of data. It is true. And we will, once we're talking about history, we will go and back process segments of history. That means taking, those epochs, 2 days, crunching the ledger. That the ledger is unexecuted transactions. So we don't know if it's failed or not. We will go and crunch that and extract that rich data out, put it in files, perhaps once and for all, right? Once that's done, you don't have any other information to extract, it's in files. So easy to parallelize, to stream out. And so we will have that for all the pieces of history, so we can, take it, reduce it, crunch it, pipe that into the graph indexer to make sense out of it. Okay, so tech guys, I haven't seen your face there, but I'm confident that you're with me here. Okay, so yes, we'll have full history. Now the Firehose itself is, I'm going to show you the protocol. So just the query. That's the query you're sending. It's very simple. Okay, so you have that in the StreamingFast Proto here. It's bstream. Eventually, it renames to Firehose. That's Firehose. Bstream is Firehose. And you do a simple request that has a start block and a start cursor, and eventually a stop block and different forking steps. Let's say you want the new only things that pass a certain level of irreversibility, and you have a few filters in there that you can select to shrink the data a little bit. And the response is an agnostic any field that will encode any blockchains, things like that. Same principles as apply to all these protocols. You'll get the step here. So is it a new, is it an undo signal, or is it, you've passed the reversibility plus that cursor. And, if you give it the start block of 1, it'll just pipe in your face the whole history. And if each time you have a message there, you get a cursor, you can interrupt the stream and then start again with cursor. It'll continue exactly where it left off. Give it the start block of -10, it'll start 10 blocks from head. A stop block, you can give it to stop at some point so you can get segments to process things in parallel. The interface is very simple, and the richness comes from the absolutely exhaustive data model that exists for each protocol, in particular Solana. And that's what makes it, so that you don't need to. There's a nice and beautiful trade-off here between, the flat aspect of files and a running beast with a lot of SSDs that you have a hard time just rebooting to catch up and all these things, or that consumes a lot of memory that you will query for it, in turn to go and query a key value store somewhere, right? And it's going to work for a certain period of time. That's really cumbersome to work with. It's not the thing data scientists like to work with. Give them flat files. Okay, stop block, do-ba-do, do-ba-da. Do you have any questions there? No. You'll send them over after, right? Okay, I still have 4 minutes. There's so much to be said about that. I'd like to see your cheering up here. I'll let you read these things later on. Did we have 20 minutes? So until 50, right? Oh, I see you now. How are you loving it right now? Show me the audience. How are you loving it? Wave. Okay, so maybe one question is when to expect that? In the coming weeks, this is being worked on actively, but the team is in the room. I don't have a fixed announcement date, but if we have a lot of cheer up and a lot of need for that, I think we can converge on on effort and making it happen sooner than later. I wanted to tell one thing. Reduce risk. Okay. Okay, what about you take questions from people in the room there? Two minutes.
Yeah. Right here. Yeah, you can come up.
Cool.
Right. Yeah, hi.
I hear you. Cool.
Awesome.
Yeah, go ahead.
Nice. First, thank you for the talk. It was very technical. I could see, well, that this must be probably pretty big on performance, like all the streaming. This is fine, but I didn't get the gist of how would I actually use your service as a front-end or back-end engineer. Are there any interfaces, frameworks to actually interact with it?
Very good question. So I've talked about the Firehose because this is the underpinning of what will be served as the graph. So you want to use the graph in the moment integration of Firehose is done. Then you'll be able to use very standard the graph ways of indexing. There'll be mappings. You'll be able to write that assembly script, and then you'll be able to map those things to entities with meaning and fields. So that's standard the graph. I highly encourage you to go to thegraph.com. Look at the docs. There's things for Ethereum right now, for Near, we just shipped. And so that's the sort of experience you'll be able to use to have a decentralized network index your things for you. So that's the value proposition of the graph. Now the Firehose in and of itself can provide value also, only for inspection and things like that. But the streaming aspect of Firehose will be there. You could hook up a lot of things to that for a bunch of different purposes. And I've shown you the interfaces, gRPC interface. That's how you would connect with a HTTPS socket, to some people like in the graph ecosystem, we're going to serve the information. Eventually, who knows, that becomes an IETF, spec that all blockchains output data in sort of in a similar consumable way, so that we can even index bridges here and there using, the Firehose output of the chain in a much more reliable way than what we have right now. Now the Firehose, all of that is also high availability ready, right? You have multiple let's say Solana validator nodes that all contribute to one or two Firehose endpoints, and that little service is a thing that can pluck up from files and stream directly, and you join from files to the real-time stream so that you don't see anything happening. You see archives and then real-time stream, and from an end user's perspective, it's just extremely reliable data from a chain, and that can be all hidden out. I don't know if that answers the question. Does it?
Well, the most direct way to interact now with Firehose would be through your GraphQL API or through the graph, right?
So most direct gRPC, and then the graph, we're going to be shipping that part where you'll actually write mappings and you won't query the thing. You'll just have it shipped in your face. There's a small WASM VM here. You'll get the data in, it'll execute, and you can store entities to a database, and then you can query it using GraphQL, right? That's the second part. First part for our house is gRPC.
All right, yeah, that makes it clear for me. Thank you.
Hey, bring on the other questions. I appreciate. It's fun to be able to, even though remote, to interact with you guys. Come on, come on. Who had challenges with Solana indexing, whatever? Raise your hand. No one had challenges. I don't believe you. Yeah, you there.
Another question.
The white shirt. Yeah, go ahead.
Hi. So my question is, suppose I want to create a new index and I want data to be indexed from like 3 months ago. How much should I wait for that? So like how fast can you like process the transactions? Okay. Suppose I want to like create a new index on all the Serum events, for example.
Yes. Okay, so we have come to the graph ecosystem because we were able to make an 800x performance increase. Why? Because the Firehose is highly parallelizable. Because you have the history, it's on disk. You have 6 months of history, it's on disk. So you can run many processes to take a chunk of history and extract them and then cobble that up into one unified view. So that's what we've done, initially. And that's why I think the attention has been brought to us and all that happened. So that can be done also eventually using the graph. We're currently working on parallelism in the graph so that we could bring that sort of crazy throughput. But then after that, just think it, you spin off more machines. And then eventually that gets, trickled down to the decentralized ecosystem. So maybe if you have if you have a petabyte of data, you'll pay a little bit more maybe for the initial sync, but at least it'll be possible, right, to get it out of there because the technology allows it. Right now, most systems will go linearly, and they'll just go through the information linearly, and that is going to take like absurdly amounts of time. If we don't have a system like that where we decouple data, and we don't have a possibility for parallelism, we're dead in the water. Like blockchains are ever growing things, social database. Everyone writes into your database, so you need to be ready for crazy scale. And I think the Firehose pattern there applied to different chains that we have experience with, that is the solution. And I've seen other things in the ecosystem trying to wire in directly into the Solana validator node, writing to databases. I think it's great. I'm happy that this happens, it's innovation, but I've seen that time and time over again, that the Solana validator being directly linked with some other database systems is inevitably going to be brittle. You want that distinction. You want that clear data-centric interface between systems. Makes things much easier. You decoupling like that. So maybe I used your question for a tangent, but does that answer the question?
Yes. So, but in order for the code to work like faster, I should make sure that my code doesn't depend on the linear, that the execution is linear, right?
Yeah. Well, we took a subgraph that was based on the fact that it's not linear, doing sums and whatever, and we made it in stages so that summation at one stage would be then in a relative way for a small segment of history, was then cobbled up in an absolute way at the next stage. So there's ways, slice and dice. If you have files, you can smash, slice and dice in different directions to increase performance. So I don't think that would be a necessary compromise.
Okay. Thanks. That was really helpful.
Pleasure. Come on.
We got one question over here.
Go ahead.
Side. Go ahead, John.
Hi, thanks for the talk. It was great. Have you thought about when Solana is working with other chains, so like with Metaplex storing Arweave data and stuff, you're getting like a snapshot view of what the world was like at that moment in time, but if it's like a mutable NFT and you're querying like past events on Solana, but the data's changed on Arweave at the point of query, are you thinking about how to represent like external dependencies?
Yes. Okay. So the Firehose is not in play here. Firehose gives you data of what happened in the richest way. Now the graphs ecosystem is working on that issue because obviously an NFT won't store everything on chain, and you will want to have these things synced. So there's a design that's put out right now and is being worked on so that Arweaves, IPFS, and other things can be synced in a deterministic way, which is crazy. But and you'll be able to index things that are, so let's say receive a signal on chain in an account says, oh, this is the pointer on Arweave. Well, you'll be able to go and fetch it and bring it into the indexing flow, so that certain fields that depend on it would be present, still being in a decentralized network. So these things are being worked on. But right now, you can use IPFS, fetchers in the subgraphs that go through Ethereum. So, but there's more challenges than meet the eye here. But I think you're aware, right? This is actively being worked on, and it's going to come up together. But one is needed, the other is needed too. There's no history right now. There's just zero history. How do you get the history? You can't. You pull the node as it's going. So that's one thing. Pulling nodes that are fast paced is crazy. It's absurd. You're going to miss some data. The only way to work that is to pipe it out to make sure you miss nothing and have sort of fixed commit at the end of each block. Even though if in the end Solana nodes output only one block out of 5, and you have 5 nodes contributing streaming blocks, and so the Firehose can be the one that sort of gets the fuses the different contribution of data extraction if we're worried about performance or things like that. So there's many things. When we decide to decouple data from the nodes, there's many things that we could do to speed up data systems and filter and reduce and whatever. Okay. What else?
So we're about to wrap up. We're running short on time here. I'm not sure.
Of course.
Yeah. So thank you so much for joining us today.